This video is a quick addendum to the lesson on inverse trig functions that's covered in section 8.4, and we're going to be just looking at one or two examples from the class notes and example sheet for section 8.4 that we didn't quite get to in class. So we're looking on the class notes and example sheet. Down on the back side, flip over the back side, and there's an example here. It should have letter A, and you can see we want to figure out what the sign of the inverse cotangent of 4/3 is. Now you might think, when you first look at this, that this would be a problem for which you need your calculator. But the idea is to do this problem without your calculator and to come up with an exact value. This actually is a problem that you have done before. It's just, it doesn't look the same as when you first did it. First of all, let's identify what this 4/3 is. Is it an angle or is it a ratio? And since we're taking the inverse cotangent of it, we know that the 4/3 is a ratio, right? And that we're looking for an angle, right? The inverse cotangent of 4/3 is some angle, and we can call that angle theta. All right? So this problem is asking us, what's the sign of theta? Okay? If, and what do we know about theta? We know that the cotangent of theta, right, is equal to 4/3. And there's one other thing that we know about theta. Since this 4/3 is a positive number, and we're taking the inverse cotangent of a positive number, that means we know that theta must be in what quadrant? Trying to write this. Right, we know theta must be in the first quadrant, right? Because any positive input for an inverse trig function must give us an angle. The output must be an angle that's in the first quadrant. Here, I need to finish writing the word quadrant. Okay, so if you think about it, you've actually done a problem like this. Or several problems like this, where you knew what the value of one of the trig functions was, and you were being asked to find a different trig function. And you may recall there's a couple of ways to go about dealing with this. You can decide to stay on the unit circle if you like, but this is where I really might encourage you to go with the x, y, r method that we've used in the past. So what we do is we recognize that the cotangent of theta is usually given by x over y, right? Remember, tangent is y over x, so the reciprocal of that would mean that we have, whoops, can't seem to write over here, x over y, all right? So that means that x equals 4 and y equals 3, right? And we simply need to figure out what r is. All right. Now remember, we're not on the unit circle. Okay. We know we have an angle that's in the first quadrant. It's somewhere about right here. Let's see. We know that the x is 4. So here's 4. The y is 3. And we need to figure out what r is. And of course we have the right triangle. So we're just going to use the fact that r squared equals x squared plus y squared. All right, and since we've got the 3 and the 4, hopefully you've already recognized this is a Pythagorean triple, but r squared will equal 16 plus 9, and therefore r squared is 25, so r will quickly be 5. Alright, and now that we have x, y, and r, we know they're all positive, we need the sine. So the sine of theta, of course theta is our angle in standard position here, so the sine of theta is simply going to be our y over our r, and so that would give us what, 3 over 5. Alright, so that's probably the easiest way to do that. Now if you prefer to stay on the unit circle, then you're going to have to use one of the Pythagorean identities, and in this case you need to use the Pythagorean identity that involves cotangent, which isn't, the easiest one to remember. Just kind of as a quick refresher, the one that you should know is that the sine squared of theta plus the cosine squared of theta, right, equals 1. So if you want to get cotangent, and in this case you'll get cotangent squared, you need cosine over sine. So that means we need to divide cosine squared theta by sine squared theta. Alright, and if we're dividing that by sine squared theta, we also need to divide everything by sine squared theta on both sides of this equation. So 1 over sine squared theta. And that gives us the identity you need. That would give us 1 plus cotangent squared theta equals, and we got 1 over sine squared. Remember, that's going to be cosecant squared theta. Alright, so if you want to use that identity, you may. Here, let me move the writing up. And so you should be able to first figure out what the cosecant of theta is. And once you know the cosecant, then you can, of course, flip it over and you can figure out what the sine is, and then you're done, right? So that is another way to do it. I personally think the XYR way is the easiest. So why don't you give example B a try. You can see it does look kind of similar to example A, though it's a negative 4/3 now instead of a positive 4/3. So see if that does anything to your answer. Alright, why don't you pause the video and give that a try. Alright, see if this is what you got. Perhaps you might be surprised that you're actually going to get the same answer, even though we changed that 4/3 to negative. But all that means is that our angle now is in the second quadrant. So we're just given -4 for x, +3 for y. R, by the way, will always be positive, so it just ends up being +5, and our sine is still 3 over 5. Alright. Well, I hope these two examples have helped, and you will see a couple of problems like them on the, I think it's worksheet 3 for section 8.4, and I apologize that we didn't have a chance to get to them, but now you have a video that can help you do them. Alright. I will see you in class.